is video R2, and we're going to do a quick review of systems of equations and inequalities. We're going to use this particular system for our review of equations, and it's a very simple one. 2x plus 3y is equal to negative 3, and 4x plus 6y is equal to negative 6. We have several ways that we could solve this system. Let's talk first of all about what happens if we change it to slope-intercept form. Now you can do all of that by hand. You just solve for y. When I do that, I get y is equal to negative 2/3 x minus 1, and y equals negative 2/3 x minus 1. I can do all of that by hand, or just a reminder, you can also do that on your calculator. You've got a program that will change the form of the line. Go to Program, Algebra 2, and Line. And remember, it's asking you for what input you have. And the input I have is, this is in the form ax plus by equals c. If I know what input I have, it'll give me back various forms of the line. So in this particular case, it gives me back y equals negative 2/3 x minus 1, and y equals negative 2/3 x minus 1. But what does that tell me? Well, if I have changed these to slope-intercept form, I need to look at a series of information about my equations. I need to look at the y-intercepts, I need to look at the slopes of the line, and then I can tell a couple of things. I can tell about the graphs, and I can tell about the number of solutions. So what do we have in this particular case? Well, we have the same y-intercepts. Remember that the y-intercept is this last number, the b part. Y equals mx plus b. They're both minus 1. So I have the same y-intercept. I also have the same slope. This is negative 2/3, this is negative 2/3. That means this is the same line. We call that collinear. Just basically, they both are graphing exactly the same line, which means we have an infinite number of solutions. One warning here, if this had been set up to where something's on the wrong side, make sure you remember, if you change sides of the equal sign, in order to get this in the right format to put in your calculator, you need to change the sign of whatever you move. Okay, well, what if this had not been the same line? What other options do we have? Well, we could have different y-intercepts. This last number here at the end could have been different, but still have the same slope. Well, if you have the same slope, the different y-intercepts, you have parallel lines. And if you have parallel lines, there are no solutions. They're never going to intersect. The other possibility is your y-intercept could be either the same or it could be different. In this last situation, the y-intercepts are kind of irrelevant. What matters is they have different slopes. No matter what the y-intercepts are, if the slopes are different, you have intersecting lines. They are going to cross. There's going to be exactly one solution. They are going to cross at a particular point. All right, just a reminder, you've got other options on how to solve systems like this. First of all, you have a program on your calculator called Algebra 2, and you can go to System and solve this. This would be a 2-variable system. You can also graph both lines and then do second, calc, intersect in order to find the point of intersection. Remember, the point of intersection is the solution to your system. Or you can use substitution. You can take one equation, solve it for a variable, plug it into the other one, or you can use elimination. I'm going to be really honest. If you're looking at a system of equations on the EOC, do this. All right? That means that you're going to have to get it in this form. That's the form that the program takes. They need to be in ax plus by equals c. And you need to remember, if you change sides, you change signs. But just put it in the program and solve it. Or graph it into the point of intersection. You need to be able to move quickly. I would not, unless they've stuck variables in it, I wouldn't try to solve it by hand. Just do it the easy way on the EOC. You're trying to get done quickly. But be careful that you're putting everything in with the correct sign. All right, that's a inequalities. Now, a system of inequalities, you're probably going to want to draw out. It's usually easier if you have things in slope-intercept form. If you don't already have them in slope-intercept form, put them in slope-intercept form. So I'm going to use those two equations. Y is greater than negative 2x minus 1, and y is less than or equal to 3x. And then I'm going to graph both of these lines. A couple of things to remember about graphing lines. First of all, we can start at the y-intercept and then move according to the slope. And second of all, when you're doing inequalities, you need to pay attention to whether this includes the equal sign or does not. So this first one has a y-intercept of negative 1 and a slope of negative 2. Now remember, it's a y-intercept. This is your y-axis. It's where it crosses your y-axis. So I'm at negative 1, and then I'm going to go down 2 and over 1 to get to my next point. So I'm going to graph in this line. It's the boundary line for my system. Now, is that a dotted line or a solid line? Solid line. If this looks like this or like this, it's going to be a dotted line. If it includes the equal sign, it's going to be solid. Well, this particular one does not include the equal to sign, so this is going to be a dotted line, and I'm going to dot in this line. Now, at this point, you can either go ahead and shade this one, or you can graph the other one before you start shading. I'm going to, I think, in this particular case, go ahead and shade it. So I'm going to change this red just to make it easier to see. And I need to figure out which side I want to shade. Well, if 0, 0 is not on the line, it makes a good test point. So I'm going to test 0, 0. If I come back and put 0, 0 in this, I get 0 is greater than negative 1. And that's a true statement for 0, 0, which means I want to shade this side of the line. So I'm going to shade in everything on this side of that dotted line. And I'm going to shade it in red. I'm going to get a very good shading here. So you can tell I've shaded everything on that side of the line. So let's go back and make this black again so I can draw my other line. What's my y-intercept here? Right? There's no number out here. Which means my y-intercept is 0. My slope is 3. So up 3 over 1. In this case, this is a solid line. It's got an equal to included. So I'm going to draw this one in as a solid line. Now, since it goes through 0, 0, can I use 0, 0 as my test point? Absolutely not. I'm going to pick another point. Doesn't really matter what point. I'm going to pick 2, 1. I'm going to come right out here and pick the point 2, 1 as my test point. So if I put 2, 1 in here, 1 is less than or equal to 3 times 2. Is that true? Absolutely, that's true. So let's make this one green. And we're going to shade the side of the solid line that includes the 2, 1, which means I'm going to shade right through here. Everything to the right of that line. So what's the solution? The solution to your system of inequalities is the part you shaded every time. And you could have shaded several different lines, but the part you shade every time is your solution. And it includes the boundary line if it's solid, which means it includes this part of the boundary line right here. And then it includes all of this on this side that I shaded with both my red and my green, including this little piece right there, right, before I get to my dotted line. So all of this is the solution. Now, it doesn't include this. This is still a dotted line. It does not include the boundary line on that side. So systems of inequalities. May run into that on the EOC. So make sure you've done all of your practice problems and your quiz for this section in getting ready for your end of course assessment.